All right, y'all. So first I'm going to give y'all a few definition type things. And then I'm going to use MathLab to actually do the problems on, okay? Because they've already got the graphs drawn for the first two. So 4.8 deals with applications of polynomials. All right, let me let one in real quick. And really, the polynomials we're going to look at are going to be quadratic. So quadratic. So those are the ones with the x squared terms, remember? So sort of what we've been messing with all week. So the first thing I want to let y'all know is x-intercepts. And y'all, you've probably heard of x-intercepts before, but x-intercepts, these are the ordered pairs of the points where the graph crosses the x-axis. Okay, so if it's crossing the x-axis with your parabola, we call them the real zeros or the real solutions. So the x-intercepts are actually them points where it's crossing that graph on the x-axis. And remember, the y value, so the y value of the x-intercept is 0. So your x-intercept will have some number for the x, comma, 0 for the y. Because remember, that's the y value if you're on the x-axis. All right, then the solutions. Now, we've been finding solutions to our quadratics by, we factored the other day, we did the square roots the other day, and we did the quadratic formula. But y'all, if you're looking at a graph of this quadratic, then the solutions are equal to the x value of the x-intercept. So if I know these x-intercepts, those x values are the solutions to your quadratic equation. That means if you was to plug each one of them into the equation, you would get a true statement out of that, okay? So y'all, what we're going to do, let one in real quick. We're going to go to the math lab, and I'm going to pull up the first two problems. And it's going to have a parabola, and it's going to ask us for the x-intercepts of that graph, and then it's going to want to know the solutions. So y'all, let me share our screen, because it's easier doing it on the math lab than me trying to draw these. And I'm going to make this a little bigger for us. So over here, it says the x-intercepts are blank, and they're showing me the graph of the x squared minus 2x minus 8. So remember, x-intercepts have to have a parentheses for them. So y'all, I'm going to put my cursor on the first x-intercept on the left side where they got the black dot. And let's see what that x value is. So it looks like -1. So that's at -2. So the x value of that point would be -2, comma. And y'all remember, we said the y value had to be 0 to be on the x-axis. You're going to close that parenthesis, then do a comma, and open up your next parentheses. So y'all, I got a point on the right side. What is that one?
Be 4, 0.
4, 0. So let's go 4, 0. Close our parentheses. Now, remember, this is a two-parter, so once we check our answer on that first one, so we didn't like that answer. So then, what did we say about the solutions to this graph? So we said that the solutions were equal to
the x-intercept.
Yeah, so what's those two numbers?
-2 and 4.
-2, 4. So y'all, once you got the x-intercepts, you got your solutions, okay? So we're wanting y'all to realize that if you don't know how to factor and stuff, you can graph these equations and get those answers because they're going to be equal to where these are crossing over that x-axis. All right, y'all, so y'all got that, and so we're going to slide to the next one. All right, let me make this one a little bit bigger.
It's going to be -1 and 4. I mean, -1 and 0 and 4 and 0.
All right, so let me catch up with you. So -1, 0. Good job. You caught yourself and put that in them parentheses. And then what was that other one?
4, +4 and 0.
Okay. So 4, 0. Oops, I must have went off the screen. Here we go. Let me get back in there. 4, 0. Close parentheses. And y'all notice when I put a parenthesis, it opens them in red, and it won't blacken them out until you put your closing parentheses. All right, y'all, so I think I got it in there like y'all said. All right, so how about the solutions?
-2 and
-1 and 4, yeah.
-1 and 4. Yeah, y'all right. -1 and 4, perfect, because it's them x values. All right, y'all, now the next one I'm going to write down, and then we're going to go work this on our pad before we put this answer in. Now I'm going to get the main things down, okay? So it tells me a wire is stretched from the ground to the top of an antenna tower. And the wire is 30 feet long. So on this problem, we're going to learn our second formula of the week. Now notice what it says. The height of the tower. The height of the tower. I'm getting somebody's background. Let's see. All right. So the height of the tower is 6 feet greater than the distance D from the tower's base to the end of the wire. So they want us to find that distance D from the base to the wire, and then they want us to figure out how tall that tower is. So y'all, the main thing I needed was that the wire was 30 feet long, and the height of my tower is 6 greater than that distance D. So y'all, I got what I need wrote down. So I'm going to tell you what, since this is a word problem, I'm going to actually draw a picture of this. So here's my tower. So what they're saying is you got a wire that's near the top of your tower, and they stretched it down to the ground. Okay. They told me this wire right here was 30 feet long. Then remember they said, hey, the height of this tower over here is 6 feet greater than the distance D. And the distance D, they said, was this distance from the base of the tower to the end of the wire here. So we know this is D because they said that was that distance there. So y'all, using the same variable D, what could I write as the height of the tower over here? Based on what they gave us right here.
6 feet.
Oh, I heard
8 feet. Oh.
The 6 feet greater, so would it be 36?
Well, don't multiply. What I just want you to do is write this side using that variable of a D. And y'all just said what? It is 6 greater. So remember, 6 greater than D would be what? D.
Oh, greater than D.
D plus my 6. Yeah. So they wanted us to use the same variable in here. So if you used X here, this would have been an X plus 6 and so on. So y'all notice what I got? A 30-foot wire. And then my tower was 6 feet greater than D. And then D was this distance down here. So y'all, I'm going to show you what we got. This is a 90-degree angle. Looks like the corner of a square. That is what we call a right angle. Which means this here is what we call a right triangle. And there's a nice, famous formula that y'all might know that relates the 3 sides of a right triangle. So y'all remember that one? So y'all want me to get y'all started on it? How about this? A squared.
Plus B squared equals C squared.
Okay, I knew y'all knew it. And that is what? The Pythagorean theorem. So it's got to be a right triangle. Now, the only thing this formula is picky about is which side we make the C. So the C has to be this longest side. Y'all remember what that's called?
The slope.
Well, it's got a slope to it, but there's a special name they call the longest side of a right triangle. Starts with a H. All right, I'm going to spell it out, y'all. Y'all remember that word? The hypotenuse.
Oh, yeah.
So that's got to be the C. The C always has to be that longest side. And then A and B don't matter what we make them. So I usually just go A and B in order. Because what I got to do is replace these A, B, and C's with what I know for each of them sides. So we know A squared. Well, the A for me is this side here. So I got a D squared I'm going to put in there. Plus B squared. Well, I'll let this be my B side. So that's a D plus 6 squared. That's going to equal my C squared, which I'll let be my side with the 30. So we're going to have our 30 and square that. So now, first thing we got to do to this, can't do nothing with that D squared, so I'll just bring that down. But we got to figure out what a D plus 6 squared is. So y'all, that might require a little side work for us. On the side, we need to FOIL this and do a D plus 6 times a D plus 6. Remember, anytime we got a binomial being squared, we write that twice and FOIL. So the D times D gives me a D squared. The D times 6 gives me a 6D. All right, 6 times D gives me a 6D. And then 6 times 6 will give me 36. Now, y'all, the biggest mistake I see on this right here is people try to cancel these out in the middle. Look, those don't cancel. They're both positive. So we're going to add them together as like terms because they don't cancel. So bring this D squared down. 6D plus 6D gives us 12D. And then bring down your 36. So we can replace this D plus 6 squared with what we just FOILed out. So that we get plus a D squared plus your 12D plus 36. And then y'all 30 squared. Well, that's what? 30 times 30? So punch that in and see what we get.
900.
900. All right, so the first thing we want to do, look over here on the left side. We got like terms. So we're going to add them together. Now remember, when I add stuff, I am not going to change those exponents, okay? I'm just going to add 1d squared plus 1d squared. I'm going to get 2d squared plus my 12d plus 36 is going to equal 900. So y'all see this d squared is the same thing as the x squared. We now have a quadratic equation. So my first question to y'all, right where that 900 sitting, what number do I need to get on this side? If I'm going to solve this by either factoring or even the
36.
huh?
The 36.
Well, no, y'all remember when I had that ax squared plus bx plus c equaled what? What did I say? We're pretty much going to set every equation equal to in this class.
0.
0. There you go. So this needs to be a 0. So y'all to make that a 0 here,
The A sign.
come over here and subtract 900 from both sides. So you bring down your 2d squared plus my 12d. Oh, y'all, that's a negative something. So 36 minus 900. Are y'all getting what? 864 negative?
Yeah, 864.
Okay. And then
That-
900 is 0. All right. So we got it in the form of a quadratic equation. Everything on one side equal to 0. Now, y'all, these are sort of big numbers. 2d squared, 12d minus 864 equals 0. Is there a number that I could divide everything by that might make this a little nicer?
4.
Well, my 2 don't divide by 4.
I was gonna say 2.
A
Yeah.
2.
Yeah, since if I do something to both sides, I can make these numbers smaller as long as they all got a common factor. So if I come in here and divide all them by 2, we'll have smaller numbers to play with. As long as we divide 0 by 2. But y'all, guess what? We're not changing the right side, are we? 0 divided by 2 is still going to be a 0, right? But look what happens here. 2 divided by 2 gives me 1d squared. 12 divided by 2 gives me 6d. All right, 864 divided by 2 is going to give me what? 430. No, 432.
432.
There we go.
Yeah.
Which now I can find factors of 432 instead of factors of that 864. So y'all, I've got my equation simplified as far as I can go, equal to 0. So now I'm going to try to factor this so that I can get my factors here. So the d squared was a d and a d. Now, that 432 is negative. So we're going to have unlike signs no matter what. Okay? So what I'm going to find are going to be factors of 432, because that's that last number. I'm going to find factors of 432 that'll subtract and give me 6. So remember, that last negative tells you 2 things. You got unlike signs, and then factors of 432 got to subtract and get that 6. All right, y'all. So remember that number, 432. Watch what I'm going to show you. The calculator can find all these factors for us. So I'm going to share my calculator.
Now you tell us that he can do this. Because them last two assignments.
Yeah. Well, these weren't bad numbers like these here 432s and 600 and somethings. But here's what you do. The number I want the factors for is 432. So I'm going to put in my 432. And I'm going to divide by X. So what this is doing is it'll start dividing by 1, then 2, then 3, all the way through. So, and I want to go to my table, so I'm going to hit second graph. So notice right here, I got an error. Because 0 ain't a factor of anything, is it? I mean, it is if the answer is 0, but if you want factors of 432, they got to start at 1. So let me arrow down.
Hello.
So y'all look at that.
We outside.
Huh?
We outside.
I think there's somebody on the phone, Mr. Eugene.
Oh, okay.
The kids come to get their car.
I can't mute them because I can't see
They
them.
come to get Javon's car.
Let me see if I can.
They going to get some food. There's Mama.
All right, I think I got it. Okay. All right. So y'all, any of these numbers that don't have decimals are factors. 1 and 432, 2 and 16, 3 and 144, 6 and 72.
And you said, do any of them not factor, Mr. Eugene?
Any of them that ain't decimals are factors.
Okay, any of them that's not decimals are factors. Okay.
So let's keep going. 8 and 54. So remember, I got to get a 6 out of these two numbers. So let's keep going. It's going to be way down, ain't it? 12 and 36 is getting closer. 16 and 27 is even getting closer. So let's see what we got. How about 18 and 24? That'll work, won't it? 24 minus 18 will give me 6, right? So that's my two numbers I need, 24 and 18. But y'all, I would have kept scrolling until I got something that worked. Now they're starting to repeat and go the other way. So yeah, just scroll through these numbers when you got to find factors. So now, let me let one in. Now that I know it's 24 and 18, remember the larger number here, the larger number has the same sign as the middle number. So that 6 is positive. That means that 25 is going to be positive, and the 18 will be negative. And you can check 24 minus 18 gives me 6. 24 times that negative 18 gives me that negative 432. All right, y'all, so here we go. We're going to set both of these equal to 0. Solve these both. So here we'll subtract 24. D equals a negative 24. Here we'll add 18. D equals 18. So here's my question to y'all. How long is this side D? You got two answers to choose from. And remember, we're in the real world here. So what y'all going with? Negative 24 or 18?
I'm gonna say 18.
18.
18, because we don't do distances with negative numbers. So on these, when I get a negative number, I cross it out because my distance can't be negative. So that D has to be 18 right there. So y'all, let's go back, put in our 18 on that little math lab. So we would come in and put 18 for the distance. Then guess what? It wants to know what's the height of that tower. Well, remember the height was D plus 6. Well, y'all, we know D was 18. So what? 18 plus 6 gives us 24. Okay, so once you got that D, you can add that 6 and get that right side. Okay? And then check answer and go to the next. All right, y'all, so let me write this down real quick. What's the gist of this one? So the foot of an extension ladder is 9 feet from a wall. So foot of ladder, 9 feet from the wall. Oh, and then look at that. The height the ladder reaches on the wall and the length of the ladder are consecutive integers. Now look what they say. All they want to know, how long is the ladder? Okay, so I got my stuff. I needed 9 feet from the wall, and then the height of the ladder on the wall and the length of this ladder are consecutive integers. So let's play with this. All right, so there's my info from it. So I'm going to draw me a picture here. So y'all, right here is my wall. And then we got us a ladder leaning up against it. Okay. So what they're telling me right now, the foot of this ladder right here is 9 feet from my wall. So I know this bottom distance right here is 9 feet. Now, the height of the ladder on the wall, so this height over here and the length of this ladder are consecutive integers. So what does that mean, consecutive integers? So remember, integers can be negative numbers or positive numbers. So when they say consecutive integers, they mean 2 in a row. So my question is, how can I go from one integer to the next integer? And then from that integer to the next integer. What are you doing? 2 to 3, 3 to 4, 4 to 5, 5 to 6. What am I doing to those? All right, let me ask y'all this then. If I was a 5, what would you do to my 5 to get me to the next number?
Go up a number?
Go up a number or add 1 to it, right?
Yeah, add 1 to it, yeah.
So here's what I say. If I let the height of this wall be X, and they said that this height here and the length of the ladder are consecutive integers, if I let this be X, what's this side going to be? Y'all just told me I'm going to go up by
X plus 1.
X plus 1. Okay. So remember, consecutive integers means 2 in a row. So any integer you give me, I can add 1 and get to the next number, okay? So look what I got again. I've got another right triangle, which means we're going to do our a squared plus b squared equals c squared. So remember, the only stipulation is this long side where the ladder is, it's got to be my c, and I'll just let this be a and b. So a squared would be 9 squared plus my b side, which will be x squared. That's going to equal c, which is x plus 1 squared. Now, y'all, here's the thing. Let me let one in real quick. The only difference on y'all's problem will be this distance right here. You're going to have consecutive integers, so you're going to have the x here and the x plus 1 there, just like me. Only difference is going to be that 9 might be different, okay? Oh, y'all, 9 squared. 81 plus x squared. Can't do nothing with that yet. But y'all, guess what we get to do? We get to play on the side again and figure out x plus 1 squared. Now, y'all, here's what's nice about this. whatever I get right here for the x plus 1 squared, when y'all do this problem, you're already going to know what it equals because it's going to equal the same thing every time. So come in with these x plus 1s twice. And then let's FOIL. X times x is our x squared. X times 1 is 1x. 1 times x is 1x. And then 1 times 1 is 1. And remember, you always got to add the like terms in the middle. So we get our x squared plus 2x's plus 1. So y'all save that because y'all just be the same answer. So put that right here. X squared plus 2x plus 1. And like I said, the only difference between y'all and me at this point will be my 81. Y'all might get something else there. So y'all guess what? We got x squared terms. So we want to start out with the x squared terms so we can get everything on one side equal to 0. So y'all, to move this x squared, since it's positive, I got to subtract it. But look what happens when I subtract that x squared from both sides. Well, over here, I got my 81. These x squareds canceled out on that side. But y'all, guess what? They canceled out on this side too, didn't they? So all that's left over here is a 2x plus 1. So y'all, here's a nice little rule about equations. If you got the same variable with the same number in front of it on either side of the equals, they will always cancel out, okay? So guess what? It's no longer a quadratic equation. So all we got to do now, since there's only an x left, is solve that for that x. So see, it worked out a little nicer than that wire problem did, okay? But if I'm going to solve this for the x, well, y'all, let's subtract 1 from both sides. 81 minus 1 leaves me 80. That's going to equal that 2x. And y'all, one more move. I'm going to take both sides and divide by that 2. So that now I get a 40 over here. The 2's cancel, making that a 1x. So the question of the day: how long is my ladder?
40.
Oh, well, let's see. We just solved this for the x, right? So here's the x.
41.
41. So yeah, this one, you got to know the height of the wall to get to the ladder, but they're not asking for that height. They just wanted this ladder over here. And y'all did 40 plus 1 and made that a 41, okay? So we're going to put that in Math Lab real quick. So yeah, that didn't want both. Just that 41 and then be done. All right, y'all. So that was 4-8. The 2 graphs and then the the 2 graphs and then the 2 word problems there. So now what I was going to do was a little bit of support for 4.8, and then we'll get into the 7.5 for college algebra. So this will be support for 4.8. All right, so they'll have you start out multiplying. They'll say multiply v minus 4d squared. Well, remember what we just did on that with them x plus ones. Anything we got squared inside parentheses, we're going to write it twice. And then we're going to FOIL. So y'all, V times V is a
2V.
V squared.
Oh, V squared.
And so V times V was a V squared. So I did that. Now, V times a negative 4D is a negative 4DV. I just keep mine in alphabetical order so that I can look at my like terms better. Now here, negative 4D times V is a negative 4DV. And then y'all, what do y'all get right here? Multiply this for me. Negative 4D times a negative 4D.
Positive 16D.
Positive 16D. You know what? You're like 99% there. But you got a D times a D. So that's going to make that what?
Squared.
D squared. There you go. All right, y'all. The only other thing we can do on this one, because they don't want me to solve it, they just wanted me to multiply that out. So all I got is these like terms in the middle. So my V squared, negative 4 gives us a negative 8dV, and then bring down our positive 16D squared. All right, so the second one's doing the same thing. So y'all try this one. True or false? The number 0 is never a solution of a quadratic equation. True or false? Can number 0 is never a solution of a quadratic equation? What
That's
y'all
false. That's false.
That is definitely false. And y'all, the reason you got to tell it though, you got to tell it the sentence is false because the number 0 can be a solution of a quadratic equation if the number is substituted into the original equation and the result is a true statement. Then that means that number is a solution, okay? And y'all, just to prove that, watch my next problem. We're going to solve t squared plus 3t equals 0. And y'all, I'm going to solve this from a different form of factoring. Because notice, I only got 2 terms here. Now, it's not like a t squared term and a number. This time I got the t squared term and a t term. So y'all, I'm going to do some special factoring on this one. The first thing I look at on factoring, is there anything common between these 2 terms here?
The T.
They both got
A t, right? So I got a greatest common factor here. So y'all, we were going to factor out one of the t's. So here's my question. If I factor out a t, what's going into parentheses?
T plus 3.
T plus 3, good job. So t squared divided by t leaves me a t. 3t divided by a t leaves me a, t squared divided by t is my t. 3t divided by t leaves me a 3, okay. But notice, I got 2 factors here. I got a t and a t plus 3. I'm going to set both of them equal to 0. Well, this one's done, which means that 0 is a solution. So anytime you got a greatest common factor like this t was, it automatically makes one of the answers a 0 if it's a greatest common factor. 0 squared plus 3 times 0. 0 plus 0 is 0. So that was true. On here, you would subtract 3. and you get t equals a -3. Well, if you square -3, you get 9, because two negatives make a positive 9. 3 times -3 is -9. So 9 and -9 add to get me 0. So both your answers got to work in those original equations. So that's the earliest thing we ever taught y'all in factoring was that GCF stuff. So right here, I factored out the GCF of a t, okay? All right, now this one says solve c squared equals 16. Now notice this one, I got the squared term and a number. What did we do the other day? Because I don't have to change nothing. I can go straight to one move and fix this.
You do the square root of 16.
So we're going to do square root of that c squared equals, and remember, this is going to be a plus or minus square root of 16. So guess what? Radical cancels the exponent. So that gives me my c. So what is it? C is plus or minus
4.
4. There you go. All right, this is the last one for this support here. So I got a plus 2r minus r squared equals 0. So y'all, let me tell you what I would do on this. I would rearrange this first. Put the r squared here, the 2r, then the 8 equals 0. But if I rearrange them, that's going to be a negative r squared plus my 2r plus my 8, all going to equal 0. So y'all, another thing I don't like. I don't like my r squared being negative. So is there a number I could divide everybody by that'll turn that negative r squared into a positive r squared?
1.
The one.
Oh, you're so close. Not a 1, but a
A -1.
-1. There you go. And I'm even going to do that to that 0 over there. But y'all, 0 divided by -1 is still going to be a 0 over there. So we're good on that side. So all we did was make the r squared positive, the 2r negative, the 8 negative, all equal to my 0. Now the factoring will be a lot easier because the r squared is going to be an r and an r. All right, y'all, remember, the last number's negative here. So remember, that last number being negative tells me we got unlike signs.
Would it be r plus 4, r minus 2?
Oh, you're so close. But remember, the larger number has to be negative like the middle. So make your 4 negative and your 2 positive. Because remember, right here, you got to be able to add them and get a -2 out of these two numbers, okay? But yeah, the factors are perfect. All right, y'all, last thing.
So the second number always has to be negative.
No, the second
Or
number. No. Well, I always put my plus and minuses here. So
Okay.
since this was negative in the middle, my larger number had to be negative. If this was
Okay.
if this was a +2, then my 4 would have been positive and my 2 would have been negative.
Okay.
It's just that your larger number here has to have that sign of that middle number, okay? All right, y'all set both of them equal to 0. So here I'm going to subtract 2. R equals a -2. And then here we'll just add 4 and get R equals a +4. And they'll give you blanks on these, so you can just put they should give you the plus or minus on this one because of the 4. Right here, you would just put 0, -3, -2, 4, and so on. All right, so that was your support for 4-8.
Can you turn it back over for a second?
Okay.
Thank you.
Uh-huh. Now we'll get into 7.5. So let me get my camera moved up, I think. All righty, y'all. 7.5 deals with analyzing graphs. And really, the only graphs we're going to analyze are our quadratics, okay? And remember, quadratics are going to be those U-shaped parabolas. So remember, these parabolas can be up or they can be down. So we've already looked at the places where they cross the x-axis, the x-intercepts and all that fun stuff. Well, what we want to focus on now is this bottom point here, the minimum point on this one, or it's the maximum point if it's turned upside down. This little point, we call that the vertex. So we're going to look at vertex first. A vertex is the ordered pair that represents the minimum or maximum point of the parabola. Okay, so if it's like this, it's going to be a minimum. If it's flipped over, it's a maximum. Now, we're going to cut them in half. We're going to cut them in half, like with a imaginary dotted line. This imaginary dotted line that splits the parabola in half, we call that the axis of symmetry. Sort of like when we was doing that symmetric to the y-axis stuff. But now we're going to be symmetric to our own imaginary lines, okay? Now, this is an imaginary line that splits the parabola in half. Now, the axis of symmetry comes in the form of an equation. Now, if this is an imaginary vertical line, y'all just got done with a test graphing lines. You had one line going horizontal and you had one going vertical. What kind of equations had the vertical lines? Was it the X's or the Y?
It was the X's.
It was the X's. So these will come in the equation form. X equals some number. And watch what's fun. Where the A is equal to the X value of the vertex. So if I know this vertex point, whatever its X value is, this line will be X equals that number, okay? All right, another thing we can get off these vertex, the minimum or the maximum. So I use the X value to get the line of symmetry. the minimum or maximum, those are equal to the y values of the vertex. Okay. Now, if I draw an x squared graph, it makes a U-shaped. Okay. So if this x squared term is positive, well, if my x squared term is positive, I'm going to have a U, which means I have a minimum. So if the x squared term's positive, you have a minimum. Now, y'all just had a test. What can I do to this to flip it over the x-axis or to flip it? I would make that a negative in front of that x squared, remember? If I put a negative in front of the x squared, it flips it over and it makes it a maximum. So if the x squared term is negative, you have a maximum. Okay. So let me give us what's going to help us find the vertex is the vertex formula. Now remember, we said the vertex is the ordered pair that represents the minimum or maximum point of the parabola. So the vertex formula comes in the form of ordered pairs, which are in parentheses. To get the x value of this vertex, we do negative b over 2a. Okay, and this is part of the quadratic formula, if you remember. Now, to get the y value of the vertex, we find f of negative b over 2a. So what that means is they're going to give us a function. We're going to use that function, a, b, and c, to figure out this x value. Then we're going to put that x value into the function for the x's, evaluate it, and get our y value. Okay? So remember, these got to be in the form of ax squared plus bx plus c. Just like on the quad formula, a is in front of the x squared, b is in front of the x, c is the constant number at the end. So y'all, the best thing to do on this is work one of these and see how you do. So for our number one, we're going to find the vertex. We're going to find the axis of symmetry. We're going to find if it's a min or max. So min or max and the value. Okay, so I'm going to tell if it's a min or max, and then what is that minimum value or that maximum value. And then finally they say, hey, graph this thing. All right, so I'll use graphing paper when I get to that part. All righty, y'all. So our equation is f of x equals x squared minus 14x plus 40. Actually, let me go to MathLab and see what if it changed my problem or not, because I want to be able to graph it on here and show y'all. So I'm going to go to 2 here. All right, so let me change that problem. I'm actually going to do that one because I want to show y'all how to graph it. So we're going to do f of x equals x squared minus 16x plus 60. Okay, so let me go back to my pad. So remember, I changed it from the 1440. We're now going to do x squared minus 16x plus 60. So we'll work it the same way. But y'all, first thing I need to know, A, B, and C. Remember, A is in front of the x squared. So if there's no number there, that's going to be 1. B is in the middle, negative 16. And then C is that constant number, 60. So you pick your numbers out just like you did on the quadratic formula. So first, I'm going to get the x coordinate of the vertex. And to get the x coordinate, I do negative b over 2a. So the negative is always in the formula. So put down your negative. Now, I'm putting in a negative 16 for b. So I'm going to put it in parentheses. On the bottom, I got 2 times a. Well, that's just going to be 2 times my 1. So y'all look at that. Double negative on top. Is your positive 16. 2 times 1 is 2. And y'all look at that. 16 times 2 gives me 8. So for my vertex here, I know that the x value is an 8. So now we got to get the y value. Well, here it says the y value is f of this, which is f of 8. So f of 8, we take this equation and put an 8 in for both of these x's. So we're going to have 8 squared minus 16 times 8 plus 60. Right, y'all, let's see. What is 8 squared is 64. Minus, 16 times 8, that looks like
128.
128. There you go. And then at the end is my 60. So 64 minus 128 is a negative 64 out of these two. Negative 64 plus 60 gives me a negative 4. So I now know the y value is negative 4. So that's what I would put in for my vertex. All right, next they want the axis of symmetry. So axis of symmetry. Well, remember, that's an equation. So that's going to be what? X equals, what would y'all put there? Remember, we said right here, it's equal to the x value of that vertex.
8.
So x equals 8. Now,
Okay.
I hear you.
So hold on, let me look. Let me make sure. Hold on. Okay. The second problem. Okay, so no, the first problem where the x, where you got the x. Okay, all you did was took the 8 that you got from that answer and put it into the y.
Uh-huh. So this,
Okay.
so this is finding the x value, and then this is plugging the x value back into the
You plug it into the f of x.
uh-huh.
Okay, okay.
And that's giving us our y.
Okay.
All right, y'all. So remember this one. The x squared term is positive. So do I have a minimum or a maximum?
Minimum.
So we got a minimum. So what is the minimum value?
-4.
Negative 4. So the x becomes my line of symmetry. The y value is my min or max. So that tells me that negative 4 was farthest on the y value, that thing went down and then it came back up. Right, then we'll graph it. So y'all, here's the thing. When we graph this, the first point we gotta plot is the vertex. So vertex gotta go first. And that vertex is 8, -4. But guess what? This tool has 3 dots on it. So you're going to need 3 points. So you can solve this and get the other 2 points by factoring. You can put it in the quad formula and get the other 2 points. Because remember, x-intercepts, that gives me a point on each side. That'll give me my 3 points. So y'all, I'm going to factor that real quick to get my other 2 points. So this is for the other 2 points. So we got x squared minus 16x plus 60. So I'm going to set it equal to 0. I'm going to go to my parentheses.
Would it be x minus 6 and x minus 10?
Oh, you learned, because that positive makes both of these negative. Good job. So remember, if the last number is positive, both factors will be negative like the middle on this one, or positive if that was positive. And the factors had to add to get 16. Good job. All right, solve them by setting them equal to 0. Add 10 right here. So x is a 10, and then add 6 right here.
So I have a question,
I hear you.
Rathon. How did she get 10 and 6 again?
Oh, she was looking at the factors of 60. Now remember, if you
Oh,
don't
and
know the
16.
factors of 60, go to y equals and do 60 divided by x. So let me go to that calculator.
You got to get the factors of the bigger number always.
Yeah, that last number at the end.
Okay.
So that was what, 60? So let me do 60. And then always divide by the x. And remember, the middle number, since it was positive at the end, since that 60 was positive, we're looking for factors of 60 that'll add to get 16. So let me go to that graph table. So ooh, I'm way down far, ain't I? So let me get back up here. I would start at 1 on these. So 1 and 60, no, that don't work. 2 and 30 don't work. 3 and 20 don't work. 4 and 15 didn't work. 5 and 12 didn't work. But guess what? 6 and 10 added to get that 16. So she picked them 2. And we threw them in there. So now this is telling me x equals 10. That's the x-intercept. So I'm going to put one number at 10. 6 is an x-intercept. So I'm going to put the other point at that. So y'all, I'm going to plot these 3 points. 8, -4, 6, and 10. So let me go to the math lab. All right, so let's put in our vertex first. We said that was 8, -4. Got to be in parentheses for the vertex. And then check that answer. And then check that answer. All righty. Then it asks us for the equation for the axis of symmetry. Remember, that's got to be x equals that 8. If you don't put the x equals, it marks them wrong. All righty. Y'all told me it had a minimum, so we would go to the one that says minimum. And then y'all told me that was, let me see, -4. Check that. Then it wants me to graph it. So I always click this to enlarge the graph. So y'all, right off the bat, I'm going to pick the tool that looks like a parabola. And I'm going to come down here and plot that first point. The vertex was at 8, -4. So starting in the center, I'm going to go right 8. And then I'm going to go down 4. All right, one more. Whoops. So right there, I'm at 8, -4. I'm going to click that. Now remember, my two intercepts I found were 6 and 10. So I'm going to put one of these up here at 10 right here. 10, 0, remember. And then I'm going to put the other one over here at 6, 0. Oh, y'all, I lied. We only got to put 1 point, it looks like. Is there only 2 dots on that, ain't it? Yeah, so in this section, we're just having to put the vertex and any other point. Save that and check it. Okay? So they're being a little nicer for us, I guess. All right, y'all, let me see what they got next. All right, y'all, so let me write this one down. F of x equals 2x squared plus 14x plus 22. All righty, so let me go back to my paper and let's figure all this out, and then we'll come punching in. All righty, so A, B, and C are going to be 2, 14, and 22. So remember, I want my x coordinate of my vertex first, and the x equals -b over 2a. So let's see, that's going to give me what, a -14 over 2 times 2. All right, y'all, -14 on top, can't do nothing with that. 2 times 2 gives me 4. Uh-oh, y'all. That don't divide, but can y'all reduce that -14 over 4? What would y'all reduce that to?
-7 over 2. I'm sorry.
-7 over 2. Since 14 and 4 both divide by 2, divide them 2's out and get that -7 over 2. So I know from my vertex so far, my x value is a -7 over 2. So if I'm going to find my y value, I'm finding f of what? Well, y'all, sadly, we're finding f of a -7/2. So we get to play fractions, but we don't mind because we got TI-84s, right? So putting that -7/2 in for these x's, I get 2 times -7/2 squared plus 14 times -7/2 plus 22. All right, y'all. You got to start with that exponent first. So I'm going to bring this 2 down. When you got a fraction raised to an exponent, you got to square the top and the bottom. So on top, -7 times -7 is 49. On bottom, 2 times 2 is 4. Now, y'all do realize at this point, you could have punched it in your calculator, right? All right, now I'm just bringing everything else down. But yeah, I could have punched it in my calculator just like it looks right there and hit enter and got my y value. All righty, y'all. So now I'm going to multiply these and that. So treat it like it's over a 1. Okay. So multiplying straight across. I'm going to show y'all a trick on this. You can reduce this one before you multiply if you want to save you time later. But I'm just going to multiply straight across. 2 times 49 is 98. 1 times 4 is 4. Then right here, positive times a negative, we're going to make that a negative. 14 times 7 is 98. Over 1 times 2 is 2. And then at the end, I still got a 22. So y'all, I'm having to add and subtract fractions. So at the moment, I'm just going to make the 22 look like a fraction by putting a 1 under it. But if I'm going to add all three of these fractions, what do I need? Is that ringing a bell?
Common denominators.
I got to have common denominators in order to add these fractions. So you got a 4, 2, and 1. The least common denominator is going to be the 4. Because I can change a 2 into a 4 by multiplying by 2. I can change that 1 into a 4 by multiplying this top and bottom by 4. So this one we don't have to change. It's already got a 4. If I'm going to turn this 2 into a 4, I'm going to multiply top and bottom by 2. So y'all, what are we getting here? 98 times 2.
196.
Okay, and then my bottom 2 times 2 is 4. So now they're matching. And then right here, I'm going to multiply this top and bottom by 4 to turn that 1 into a 4. So that gives me 22 times 4. Oh, that's what,
88.
88. All right. So at this moment, I'm going to put a 4 on the bottom because that's the common denominator. What we want to do is figure out what 98 minus 196 gives us. So subtract them and see what we get. 98 minus 196.
Negative 98.
So you got negative 98 plus 88. So that negative 98 from them, add 88. What's we getting? A negative negative 10.
Negative 10.
So here's my last question. What does that negative 10 over 4 reduce to?
5/2.
Let's make that a negative 5 over 2. So once again, we divided out to 2's because they were both even numbers.
And you got the negative 10/4 from where, Mr. Eugene, again?
So I did 98 minus 196. That gave me negative 98. And then when I did that negative 98 plus this 88, that gave me negative 10.
Okay.
So when you add fractions, you bring down that denominator and do everything on top. All right, y'all. So that's a negative 5 halves. Woo, that vertex is going to be fun to put in. Negative 7 halves and negative 5 halves. So y'all, we know the vertex. So what did they want to know next? So now let's go to the math lab and put this vertex in and see what it wants next. Okay, so I got my parentheses. My first fraction for the x, we got what, a negative 7 halves. So that's negative 7. Arrow down and put in my 2. I'm going to arrow right and put in a comma. And then my y value was another fraction. And what do we get? A negative 5 halves on that one. So arrow down, put in my 2. Arrow out and close my parentheses. All right, so it wants fractions. It don't want decimals on that, okay? And it don't want no mixed numbers. All righty, so the axis of symmetry. So we got everything we need for a second. What is the axis of symmetry?
Negative 7/2.
Oh, you're so close.
Is it a positive 7/2?
No, you was right with the number. But remember how they want me to put it in here.
X equals negative 7/2.
There you go. I got to act like math lab so y'all don't do that, okay? Because MATLAB will tell you something crazy like, although your answer is right, it ain't in the right form or something crazy. So does this parabola have a minimum or a maximum?
It looks like it has a minimum.
Yep, it has a minimum because that x squared term is positive. So what is that minimum value?
-5/2.
So negative
X.
5
Okay.
over 2. There you go. Now they're going to want us to graph this one. So let me enlarge. So let's see.
How did y'all get -5/2? I'm sorry.
Oh, because that was my vertex y value. See up here, I had -7/2 for the x value, -5/2 for the y value. So the axis of symmetry is always x equals whatever that x value was. The minimum or maximum is always equal to that y value.
Okay, I feel slow. I'm sorry.
Hold on, let's see. Hold on, wait. Okay, I was about to say now that she mentioned it. Okay, but I see because -10/4 simplified is
It
-5.
reduced it. There you go.
Okay. I was about to ask the same question she just asked. Okay.
No, y'all are good. It just had to reduce. Now remember, you can reduce them on your calculator. Just punch in -10/4, hit enter, and then turn that decimal back into a fraction by hitting math and enter twice, and it'll give you that 5/2. So it always gives you the most. So y'all watch this. If you don't like factoring and all that, finding those other points, we got calculators. So I'm going to go to calculator and I'm going to punch this in on it. I'm going to push that in. I'm going to go y equals and clear this out. All right, so I'm going to put it in 2x squared. So 2x squared plus 14x plus 22. Now I got it in there. So if I want more points that are going to be easy to graph, because I know I got to plot that vertex with the fractions first, but I'm going to go to this table. And woo, those are big numbers. So let me get up here to some small numbers. How about -2, 2? That's pretty small. 1 and -110 wasn't too bad. -3, -2 ain't too bad.
Yeah, that's a good one. So we can just go back and graph that if we wanted to without doing all that?
Well, we can, but we got to do that vertex. And see, this don't give you the vertex.
Hold on. Okay.
Uh-huh. So now let's go to MATLAB. I'm just going to use that -2, 2 for my second point. So remember, we're going to click it, grab the U-shaped tool. The vertex has to be first. The x value is -7/2. So y'all, if you was to take -7 divided by 2, you'd get a -3.5 out of that. So if you want help, convert them to decimals and go over here to a -3/2. And then the 5/2, if you convert that to a decimal, is a -2.5. So go down -1, -1, because it's going by halves on this. There's -2, and then there's -2.5. Whoops. Where'd it go? -2.5. Turn those fractions into decimals when you graph it. It's a lot easier. So I got my vertex, and then I picked -2, 2. So I'm going to go left to -2, up to 2. So there's my -2, 2. Plot that point and save it. So you got to plot the vertex first, but then use your y equals to get me any other number you want, okay? So what's it going to make us do? Check that, and then let's go. All right, so I'm going to skip this one's doing the same. Oh, yeah. I'll do this one. So let me write these numbers down real quick. F of x equals -x squared minus 10x minus 18. So let's work that one, get our vertex for sure. And then see what the graph looks like. So look at this. A is -1, B is -10, C is a -18. Now let's get the X by doing -B over 2A. So that's going to be a negative times my B, which is -10, over 2 times the A, which is -1. So y'all on top, I get a +10. But look at that. The bottom, I now have a -2. Woo, we're happy this one ain't a fraction because 10 divided by -2 is going to give me what, a -5. So for my vertex, I know the X value is -5. So to get the Y value, I'm going to find F of -5. So that'll be equal to a negative times -5 squared. So y'all remember that negative's in the formula. So bring it down and then put your -5, square it, minus 10 times X, which is -5, minus 18. Now, y'all, the biggest mistake you'll make on this is if you make this a positive right here. These two negatives do not make a positive because that exponent has to be worked before you multiply. So bring down this negative.
Okay, look. So remember when you told me earlier, you said we got to get the vertex?
Uh-huh.
Okay, so basically that's what you were saying. We have to get that first number right there.
Yes.
And then we can do the calculator part. Look at me, always trying to do the easy way.
Yep.
We
so
can do
then
the
you can,
calculator.
yeah, then I can, once you got this vertex and all this other information, graph it, get them other 2 points you need, and be done with it.
Okay, okay.
Mm-hmm. So y'all exponents first. So -5 times -5 is 25. So that negative outside, this is like 3 negatives, which is going to keep it negative. Right here, minus 10 times -5 will make that a plus 50, and then minus the 18. So -25 and 50 equal 25. 25 minus 18 gives us a 7. So this vertex is -5, 7. So let's go punch that in and see what else they want. They probably want the same questions we've been doing, but let's see. So this is going to be a parentheses, -5, comma 7. All right, y'all. Axis of symmetry. What are y'all putting?
-5. I mean, X equals -5.
Okay, I got you that time. Good job. So X equals -5. Does this parabola have a maximum or minimum?
Max.
Yeah, because that thing's negative in the front. So it does have a maximum. So what's the maximum value?
7.
7. All right, so let me go to my calculator real quick because I'm going to plot that in it and get my other values, okay? So Y equals, this time, I'm going to clear that. We had a negative X squared minus 10X minus 18. All right, now let's look at the graph because y'all told me I had a maximum. There you go. There's your maximum, right? So hit second graph, or yeah, to get the table. Well, I like them little numbers like -2, -2, -3, 3. So I guess I'm going to do -3, 3 for my second one. But yeah, I'd have picked out any of these little numbers up through here, okay? All righty, y'all. So this was not as bad. Grab the U-shaped tool. Vertex at -5, 7. So let's go left to -5, up 7.
So when we're looking at that table on the calculator for the second point, it's
Yeah.
best to find
Uh-huh.
a smaller number as our, I'm sorry,
Yeah.
two smaller
Now-
points as our second one.
Now look at my calculator. Look here. I'd rather plot these little numbers than, well, hell, I don't even know if the graph will go out to these 29s and 42s.
Mm-hmm.
And then see, as you get on the other side, they're going to start getting bigger again.
Bigger, yeah.
So I just arrowed that thing around until I found something I like to do, like that. -7, 3 ain't bad. -6, 6. Any of those I'd have been happy with. But boy, once it starts hitting 18, 29, 42, look here on
It's not on
MathLab.
the graph. Yeah, it's not on the
Yeah,
graph.
MathLab only going up to 10 by 10. So, yeah. All right, y'all, -3, 3. So let's see, -3, up 3. There's my -3, 3. So there's that upside down U-shaped graph we had. All right, so I'm going to time warp a little bit. Oh, let's see if this is true or false. The function f of x equals -6x squared plus 9x plus 1 has a minimum value. True or false?
See, we would have to work this out on the homework.
Well, what did we say about the x squared term to determine if it's a min or max?
Is that false?
Well, let's see. If that's a -6, it's going to flip my parabola over,
Uh-huh.
which means it don't have a minimum value. It has a maximum value, so that is definitely false.
Tell me how you could tell again by looking at the equation. You said flipping over the x squared value.
So let me go back. So let's see what it does on 5 this time. So it's going to give me another one. I'm looking at that x squared term. There's a
Okay.
-6 in front of it.
Okay.
Since it's negative, it'll have a maximum. If that was
Got
positive,
it.
it
Got
would
it.
have a minimum, okay?
Okay.
So I'm just looking at that sign, and that one we said was false. They're just trying to make you think, oh, it's negative, so it's going to be
Negative.
minimum, but no, that ain't the trace. It's
Yeah.
sort of backwards. So y'all, this one says the graph of x plus 3 squared can be obtained by translating the graph of x squared left 3 units. Is that true or false? Y'all just did these with the transitions. When I attack that x, is it adding 3 going to move me left or right?
Yeah, it's
Right.
gonna move
Adding 3 is going to move you to the right.
left. It's gonna move you left. You said positive was left.
Well, I'm hearing both of them, but yeah, when it's positive, remember, it's sort of backwards what you would think.
Oh, positive is left, negative is right.
There you go. So they said what? They said left, so that one is definitely true, okay? So on this one, what I do, it says the axis of symmetry, x minus 8 squared plus 1 is x equals 1. So, let me see. Y'all can try to graph that and look at that. So let me write that down. What is that? -3 times x minus 8 squared plus 1. Well, all that 1 did, remember, was moved it up 1 at the end. Okay. So what did that -8 do to my parabola? Because see, it's squared. So what's the -8 do when it's being subtracted?
It moves it to the right, doesn't it? We just said
Yes.
this.
So exactly. So if my graph had its minimum at the 0 on the x-axis and you moved it right 8 units, is that going to be true or false? Well, that's definitely going to be false because we're moving it over to, if that had been like an x minus 1, then that probably would have been true. We'd have moved it right 1. But y'all, we're moving this thing over 8 units, so there's no way that parabola is going to. So let me show you where we at. Let me share my paper. Because remember, our parabolas, they start out in the center. So if you moved it right 8, it's way over here at 8 is now centered like that. Well, 1 is way over here, right? So there's no way that this axis of symmetry is going to be equal to that x equals 1. So that would definitely be a, where we go? False on that one. All right, y'all. So I'm going to time warp up because I want one of these two to do with you.
Right,
So-
and I got a question for you for that homework.
Uh-huh.
But we can talk about that when you're done.
Well, the homework lets y'all work it all you want.
I know, but that last assignment you gave us, it's one of them problems that literally almost made me cry for real. Like I was about to cry.
Oh,
It was that number 10 on the last. I got through the whole thing until that one because it was. I have to. Let me
Oh, was
get
it
to
a quad formula?
Yes,
Yes.
it made
Oh,
me. It
this
almost
It
made me
gave me
cry.
a problem too.
On the
It
support
was
number
that-
10, okay, we can work one of them.
Okay.
But look what this one wants. This wants a vertex, minimum or max values. Let's see. Let me move this. Is blocking me real quick. Let me move that up. And the value. The range. Ooh, that's a new one. The range. And find the intervals of
Increase and
increasing
decrease.
and decreasing.
I
So-
wish the homework gave us the same
Oh,
numbers as
y'all ain't
yours.
seen me right, are you? My bad. I was still on Math Lab. I'm just writing down all their instructions. So before we can do this problem, I got to tell y'all what are intervals of increasing and decreasing. Okay. All right. So where's my notes? Okay. So let's look at the intervals real quick and figure out what they're talking about here. And then we'll play with this question. So intervals of increase and decrease, and then there's actually another one called constant. So we're going to be figuring out how to come up with intervals of increasing, decreasing, and constant. Now, the actual college algebra 7.5 don't do constant because it's all parabolas, but there's 3 support questions and they do add the constant interval in theirs. So here's the thing. The interval of increasing. Now y'all pay attention to this. Intervals of increasing are the x values for which the graph goes uphill left to right. Notice I didn't say nothing about y values. It's only the x values for which my graph is going uphill left to right.
Easy. Yeah. I'm Sierra. My somebody's
Say again.
sister. Tanaya and Tierra sisters. Yeah. Your name. Yeah. Say
Okay.
last name. Last name.
I got to mute someone. I'm getting back play. Okay, I think I got it. All righty. That means intervals of decreasing That's the X values for which the graph goes downhill. Left to right. So it's going to go downhill, which means intervals of constant. Y'all, those are the X values for which the graph is a horizontal line going left to right. Look right here, left, that should be left. So always read these left to right. So this is going straight across as I go to the right. So uphill, downhill, and then straight across. And it is X values, okay? So I'm going to draw a graph. X and Y. And I'm going to number this out 5. Okay, y'all. So let me figure out some points. I'm going to put a point here at -3, -1 right here. So that's -3, -1. And I'm going to put another point over here at 3, -1. All right. My line is going to go straight across right there. Connect them 2 dots. Over here, it's going uphill. And then over here. Now, here's the thing. Although they draw an arrow going here, that don't mean we're going that direction. What that means is this line goes on forever, okay? This line goes on forever. We're going to read this graph starting here, going to the right, okay? So this graph, although they got that, that just tells me that these lines go on forever. So y'all, they're going to come in and say, hey, what interval is your graph increasing on? And y'all, these intervals, we're going to put in parentheses. So it's increasing over here on the right side, right? So we're going to put our parentheses. So y'all, what X value does my graph start going uphill?
Is that 3?
That's a 3.
0, 3. Well, no, I'm sorry. 1, 3. 3, 1.
Yeah. All you're dealing with X's here, so just put the X value. Now, as I head off towards what, this graph is going uphill. So what? I started at 3. What am I headed towards out here?
Infinity?
Infinity? Okay.
So from 3 on the x-axis to infinity, this graph is going uphill. All right. Then they're going to say, hey, where is this graph you just drawn decreasing? Well, that's this part. It's decreasing as it goes left to right. All right, so what are you saying?
-3?
Okay, that's
wait.
what needs to be first.
Okay, so -1.
Well, I'm coming in from out here. Where is this?
Infinity.
Oh, infinity to -3.
So see, I'm coming in from that negative infinity. We're going downhill until we get to that -3, you said. So that's going to be negative infinity, negative
And negative
3.
3.
Uh-huh. Now, constant. Constant is that straight line going straight across. From what to what does that line go straight across?
Negative 3 to 3.
That's it. Now, did y'all notice we didn't even do nothing about that y value? We don't care about y values. All we want is these x values where it did all that. So watch this. Negative infinity, negative 3, it went downhill. From that negative 3 to 3, it was constant. And then from that 3 to infinity, it went uphill. So now that y'all know that, let's go play with that question I had. We're going to play with this, remember. So let me write this down. F of x equals x squared plus 10x plus 21. So that was our problem they gave me. Okay. So
Okay,
remember,
A, B,
we're
and
going
C.
to start out finding the vertex because we need that vertex. Actually, that vertex, once I got it, is going to answer a whole lot of these questions. So y'all, we need A, B, and C. It's going to be a 1, x squared, 10 for the x, and C is 21. We're going to get the x value, negative b over 2a. And pray we don't get a fraction, right? So that's negative b, which is 10, over 2 times a, which is 1. Ooh, we made it. We got a negative 10 over 2. That's what, a negative 5. So I know my vertex is a negative 5. So we'll get our y value by finding f of that negative 5. So it's going to be negative 5 squared plus 10 times negative 5 plus 21. All right, y'all, negative 5 squared is 25. 10 and negative 5 make that a negative 50 plus 21. Are y'all noticing this also? This second number is always twice as big as the first number in the vertex formula and opposite in sign. So if that's 25, that's automatically a negative 50 here. If this was, say, a negative 4, this would be positive 8. So it's always twice as big and opposite in sign. So y'all, 25 minus 50 is negative 25. Negative 25 plus 21 gives us a negative 4. Now, did that one tell us to graph it? I can't remember. I don't remember. So let's go back. We got negative 5, negative 4. We're going to put that in Math Lab. So remember, parentheses, negative 5, comma, negative 4, close parentheses. All righty, so it wants to know next, is this a maximum or minimum?
Minimum,
So it's a minimum of
negative 4.
negative 4. They're throwing you a curveball. See, they didn't even ask about that negative 5 on this one. They didn't even ask us for that line of symmetry. So good job. So now they want the range. So let me draw a picture of what we got here. So we know we got this parabola here. And over here at negative 5 and negative 4 is the minimum value of my parabola, right? So y'all remember the range. The range is the y values that this graph represents. So you got a negative 5 and negative 4. Which one's the y value?
The negative 4.
The negative 4 is my y value. And we said it was the minimum value. So since it's the minimum value, we're going to put it in square brackets. So the range, I always start with my minimum number and I head towards my top number, okay? So this graph, it's headed off towards what?
Is it infinity?
Yeah, because here's my minimum value, -4. And y'all, this graph goes on and on until it heads towards infinity. But remember, infinity always has a curved parenthesis. The range, you put brackets around that minimum or maximum number because it includes them, okay? So if the range is a minimum going up, you're going to have your number, then infinity. If your range is upside down, so say if it was upside down, I would start at -infinity and go to that maximum point, okay? So we had a minimum, so we got the number first. So we got to find that. Oh, I got a bracket on my computer, I think. So bracket -4, comma, infinity. Y'all got that down here. Yeah, right there. And then my curvy parentheses. So we check that and see what they want next. Increasing. Well, we got what we need for that one. So let's go back to our. So here's -5 on my x-axis. And then here was -4 on my y-axis. So get rid of that. So increasing is where this is going uphill here. So what interval am I increasing? And remember, intervals of increasing and decreasing are always in parentheses. So y'all see where it's going uphill, right?
Is that -3 or -2?
What are you looking at? This?
Yeah.
5.
But what y'all want is the x value, which is.
Okay.
See,
I'm looking at what it runs through. Okay, -5.
See,
Okay.
the y value is still that -4 stuff, but remember the x value is equal to the x value of your vertex, which is -5. So, and also, it don't only give me just that axis of symmetry, that imaginary vertical line. It also tells me the x value where this is switching from one to the other.
Got
So
it.
-5, and
To
as I head out towards
To infinity.
infinity. So this one don't have they ain't going to ask for constant on this one. When you're doing the parabolas, they're either going to be what? Increasing or decreasing. All right, so my left side's over here. So as I'm coming in from the left, my graph is going downhill from where to where?
Infinity to -5.
Negative infinity to -5.
There you go.
Negative infinity.
There you go. So the increase and decrease are not that bad, y'all. Just as long as you remember, you're only looking at the x values where that happens. We didn't care that it had a minimum of -4 when we're looking at these ranges, okay? All right, so let's go punch them in. So they're going to make us punch them in, I bet, before. So increasing, what'd y'all tell me? -5 to infinity. All right, so I would check that one real quick. And then decreasing, y'all said was -infinity.
Negative infinity to -5.
Okay, comma, -5. Shift that. And then I don't even think we got to graph those ones. So they're just going to have you go through doing that kind of stuff. So y'all, if you want, we're sort of running low on time, but if you want, I'll work this word problem real quick. It won't take long if y'all want. So are y'all down for it?
It don't matter.
I'm down.
It's about a little toy rocket gets shot vertically into the air from a launching pad 5 feet above the ground. Now this, and all you need out of this is this equation for the h of t. But they're telling me it has the initial velocity 120 and that the height above the ground at t seconds is given by this formula. So all we need is the formula. H of t equals negative 16 t squared. So t is our variable, which represents time on this one. Because the height of the rocket depends on how long it's been shot off. And then I got what, a plus 5. So notice what they want. How long till it reaches maximum height? So how long till maximum height? And then what is the maximum height? So here's the thing. Since t is my variable, t will be like my x's. H of t will be my y values. So y'all, I'm going to the pad and we're about to figure this out. So guess what? I'm going to do the vertex formula. I'm going to find out my vertex. This is be the t will be the x. The h of t will be the y. This will be the x, which is going to be how long. How long it takes is the x. The height will be the y value. Remember, our max or mins are always those y values. So we got A is negative 16, B is 120, C is 5. So let's get our x, which is really our t, by doing negative b over 2a. So it's going to be negative 120 over 2 times negative 16. Woo, y'all get a negative 120 over negative 32. So my time's got to come out positive on it. So those two negatives will make that a positive. And y'all, let's see what we get. What I have, 120 divided by 32. That gives me 3.75. That tells me it took my rocket. That's my X value now. 3.75. Since we're doing a real world problem, they will take decimals on this. Now, we're going to get that Y coordinate by finding H of 3.75. So this is probably where I'm going to let my calculator help me with these decimals. So negative 16 times 3.75 squared plus 120 times 3.75 plus at the end is a 5. So y'all, let's push that in on the calculator because that'll make that a little bit nicer. Can y'all see that calculator screen right there? Or do y'all need me to do my other one?
Yes, I can.
No, we can see it.
Okay, so let's punch it in. Negative 16 parentheses 3.75 close parentheses and square it plus 120 times 3.75 close parentheses plus 5. So y'all, where they got this formula from? The 5 was how high it was off the ground. The 120 was the initial velocity they said it had. And anytime you see a formula with negative 16 right here, that's from the pull of gravity. Okay. All right, y'all. So let's hit enter. And what did I get there? Does that look like what? 230?
230, yeah.
So there you go. We got a 230 there. So 3.75, 230. So here's my question. How long till the rocket reaches its maximum height? So what y'all putting there? How long till that rocket reaches its maximum height?
3.75.
So 3.75. And they'll have the seconds already there. All you got to do is punch into 3.75. What is the maximum height?
230.
And they'll actually have the feet there for you. So you just punch in your 230. So less than 4 seconds, my little rocket went. Ooh, that's about 20 stories because I think a building has what, 10 feet per floor, basically. Well, that's about 23 stories my little rocket went in 3.75 seconds. After that, it starts going downhill, right? Until it gets back down to 0. So that's some of the stuff I can do with my vertexes. So this one would have had something like this. And right here would have been at 3.75 seconds. And this max height right here would have been 230. So reaching that peak and then it's coming back down because of the gravity overtaking it, okay? Alrighty, y'all. So let me put this calculator up real quick. That is 7.4. Now the support was only doing 3 questions with the increase and decreasing and constant stuff. So it's like that one I showed you. So it's not bad either. I'm going to stop that share. I'm going to stop this recording and then we're going to figure out what y'all need help